it is parallel and perpendicular lines, and we're going to be looking at the equations of those. So we're going to have to kind of retrace in our head that linear function and linear equation that we've learned. So remember that parallel lines, they never cross. So they would never ever intersect at any point. Okay, so they look like this that I've drawn. Also parallel lines, so it makes sense for them to have the same slope. Okay, so if you're rising and running at the same rate, then you will have parallel lines. Do not be fooled by lines that look parallel. So they look like, so they maybe increase like this and one goes like this, and then that's the end of the graph there. Okay, so they never do intersect in the little bitty piece that you see. But remember that parallel lines, I mean, the lines just go on forever and ever. So if we were to extend those lines out of this little snippet that we have, then you would see that they do essentially cross. So do not be fooled by some sort of visual that you're given as a graph. So what I want you to know is that parallel lines have the same slope. You've got to remember that. Okay. Perpendicular lines. Perpendicular lines cross, but there's something special about their crossing. They actually cross at a 90-degree angle. So when two lines cross, it has to be at a 90-degree angle for them to be perpendicular. Okay, so when we're looking at the equation, the line there and the slopes particularly, they are going to be the opposite reciprocal. And what I mean by that is that they're going to have the opposite sign. So you're going to change a sign from either positive to negative. Okay, and if it's already negative, then you would change it to positive. And then the reciprocal is going to be when you take a fraction and you flip the denominator and the numerator. So if it goes from A to B, the reciprocal is going to be B over A. So you just flip that. Now, something that you want to keep in mind is that when you have a whole number, you can write a whole number as the whole number divided by 1. So I can write 2 as 2 over 1. And then whenever I were to flip that, that would be 1 over 2. All right, so just kind of keeping those things in mind. So you're looking specifically at the slopes of either parallel or perpendicular lines. All right, so now we're going to write the equation of the line that's parallel to the function y equals 1/2 x plus 9 and passes through a specific point, -5, 8. So in order for us to write an equation, you either have to have 2 points or you have to have a point and a slope. So since we have a slope and a point based on our equation and the other point, then we can write our equation. So the equation that's parallel to this, that means that our slope for our line is going to be the same as the slope of the function that we're finding that's parallel to it. So it's going to be 1/2. And then it passes through the line or through the point, -5, 8. So what we're going to look at here is the point slope form. So this is going to be y minus y1 is equal to m times x minus x1. Now, what's really great about this is that you will end up with the equation at the end instead of having to plug everything back in and write the equation. So what we have is we're going to have y minus y1. So y1 comes from my point right here. So it's going to be y minus 8 is equal to m, which is my slope, 1/2, times x minus my point here, which is a -5. And so therefore, I'm going to go ahead and change this to a +5. And so I'll distribute 1/2 to both of these. So this is y minus 8 is equal to 1/2 x plus 5 over 2. And then I'll end up adding 8 to both sides. So I'm ending up adding 8 to both sides, and I'm just going to add it to the 5/2 because that's my whole number. It doesn't have a variable with it. So then we end up with the equation y equals 1/2 x. And then if I add 5/2 plus 8, I end up with 10.5. So I can write it as a decimal, or you can write it as a fraction. So the fraction would be 21 over 2. So you could keep it as either one, and it does not matter. So either one of those would be acceptable. So that's how you would do a point and that's parallel. Now let's look at a line that's perpendicular. So we have the line, we're going to have to find out the slope, and then we have the point that we're going to have to name. So let's take a look here. So my slope, remember, is rise over run. So rise over run. So my rise is 3 and my run is -1. So my slope for my perpendicular line, okay, so my regular slope for my original line is going to be 3 over -1, which is -3. So to find the perpendicular line, I'm going to change the sign to positive, and then I'm going to flip 3 over 1, which is going to make 1/3. So my slope is 1/3, and then I need to go over here and I need to name this point, and it's going to be 3, -2. So I'm going to do points. I'm going to use point slope form. So have y minus y1 is equal to m times x minus x1. And so therefore I'm looking at y minus y1, which is minus a -2, okay, is equal to my slope, which is a positive 1/3 times x minus 3. So minus a negative, remember, makes a plus. I'm going to distribute 1/3. So I kind of do that all in one little swoop there. So I end up with y plus 2 is equal to 1/3 x minus 1. So 1/3 times 3 is 1. So it's a nice, pretty number this time. And then I'm going to end up subtracting 2 on each side to get rid of that. And y equals 1/3 x minus 3 is going to be the equation there. So that line is going to be perpendicular to my original line, and it's going to cross the y-axis at -3 and go through the point 3, -2. Everything good there. All right, so now we're going to identify if these lines are parallel, perpendicular, or neither. So what you want to do is you want to mainly, remember, you do not want to pay attention to anything as far as the y-intercept goes. You're strictly looking at the slope. The y-intercept out the window does not matter when you're looking at writing the equation for parallel and perpendicular lines. So when I look at these, remember, I want them to either be the same or I want them to be the opposite reciprocal, or the different signs and a flipped fraction. So if I look here, that they do have different signs, but they are not the fraction flipped. So if I were to flip 2/5, that should be for perpendicular of 5/2, which is not the same as this. So it should be either -5/2 to make it be perpendicular. That's that little lines like upside down T. And for it to be parallel, you would want it to be a positive 2/5. It's neither one of those slopes, so therefore it's going to be neither. Are they going to cross? Yes, they're going to cross somewhere. Is where they are going to cross, is it going to create a 90-degree angle? No, it's not. So this is going to be neither. So just a big key thing here is that I want you to remember that you need to look at the slopes of the lines. Nothing else matters. And then that point slope form, just kind of storing that back in your mind, it's y minus y1 is equal to m, the slope, times, so open parentheses, x minus x1. So the y1 and the x1 are where you put your points. Remember that minus a negative is going to end up being a positive. So that all those helpful hints will help you be able to create the equation of the line that's parallel or perpendicular to another line passing through a specific point.